Today we will be presenting on Becker muscular dystrophy, also known as BMD, and we will be providing some insights that we found interesting about the disease. I am Emilie, and I will talk about what causes such great phenotype variability in BMD patients. So as we know, BMD is usually caused by in-frame mutations, which are both deletions and missense mutations that are found in different areas of the dystrophin gene. And what causes such great phenotype variability in BMD patients is the location of where these mutations occur. So many studies have looked at the locations of these mutations and the phenotypes resulting from them. And what has been found is that deletions in exons 45 through 55, which are in the rod domain of the gene, only cause mild symptoms, while deletions in the first part of the gene cause very severe BMD symptoms, and this is because the first exons comprise the actin binding domain, which is essential for the functioning of the dystrophin protein. Research has also shown some consequences on cardiovascular health and the development of dilated cardiomyopathy. And what has been found is that deletions within the amino-terminal domain cause an earlier onset of DCM, and usually patients develop DCM in their mid-20s, while if the deletions and the mutations occur within the rod domain, then they will develop DCM later in life, around 40 years of age. And BMD has, as I said, a lot of phenotype variability because due to the different areas in which the mutations are found within the dystrophin gene. And as you can see, there is a wide range for the age of onset, the loss of ambulation, and death of patients affected by this disease, and the age with which a patient is diagnosed with the disease and loses ambulation and then dies is always correlated to where the mutations occur within the gene. So, for example, for the age of onset, usually people are diagnosed when they're 11 with BMD, but there is a big range. And diagnosis can occur between 2 to 21 years of age. Loss of ambulation typically occurs when patients are 27, but also there is a wide range. And finally, death has the greatest of all ranges, which usually goes from 23 to 63 years. To provide more insight on how the phenotype varies among individuals affected by BMD, I wanted to present a few stories given by patients on in which they describe their condition. For example, on the left, we have Mario, who is a 46-year-old man who is currently living with BMD. And he was diagnosed at the age of 3, but lost ambulation later when he was 24. On the other hand, Patrick was diagnosed later. He was diagnosed when he was 9 years old, but he lost ambulation significantly earlier. And he started using a wheelchair when he was 15. So as I said earlier, where the mutations occur in the dystrophin gene, in particular in which domain the mutations affect, really has diverse consequences on the phenotypes and the symptoms experienced by BMD patients.
Hi guys, this is Sricharan, and in this video I'll be talking about drugs and treatments for the Becker muscular dystrophy. All right, the first one being the anti-inflammatory steroid therapies. Basically, these are broadly used for BMD patients, and that's purely because it has shown to improve the muscle strength and also the function. Such steroids includes corticosteroids or glucocorticoids, such as prednisone. These medications have shown to help delay muscle degeneration and also retain strength. Corticosteroids also have the ability to prolong the ability to walk, and also experts think that steroids help decrease inflammation and may influence the repair of weakened muscle cell membranes. This connects back to the point of how DMD, what we've learned in DMD, how DMD helps in also certain physical therapies help decrease inflammation, and that might help cool down the sarcolemma region and thus help benefiting the patient. Mechanisms. So how do the corticosteroids perform? We look at the mechanisms of steroids effects in muscular dystrophy, and from the flow chart to the right, we can see that glucocorticosteroids increase total muscle mass and strength through insulin-like growth factor stimulation, and they also decrease cytokine production and lymphocyte reaction, and thus enhance myoblasts and other molecules. Oral corticosteroid, let's go to how corticosteroid, in what ways they're beneficial, in what other ways they're beneficial. Oral corticosteroid treatment, which is basically what's prescribed to the patients, for the most of the patients, oral corticosteroid treatment is associated with delayed cardiomyopathy, which is something. Cardiomyopathy is basically just the heart not being able to pump the blood and send it to the other part of the body. The duration of corticosteroid treatment also has a positive correlation with delayed cardiomyopathy, and we see that from clinical trials and based on the previous data, it's said that DMD, a patient who'd been treated with muscular dystrophy for about 5 years with corticosteroids had been proven to have more than about 20% increase of him having the chance of not getting cardiomyopathy than a patient who had not been treated with corticosteroids, which is obviously one of the other advantages of corticosteroids. And let's take a look at the cons of, since we've already taken a look at the pros of corticosteroids. One of the cons of the corticosteroids is that they've shown, over the past, looking at the clinical trial histories, they've also they have issues with weight gains. The patients who have taken corticosteroids have gained so much weight, and they've resulted in obese conditions, and their behavior changes, and they've also noted to have a high blood pressure. The next common issues in BMD is joint contracture, which were seen in some cases and could be prevented through physical therapies, and which help to help you promote mobility, help you move, and also reduce cramps and muscle fatigue. Again, like we said, corticosteroids are something that do promote obese condition in some patients, but obviously, aside just not looking at the treatments, what's something that you can take care of at home being a BMD patient is a healthy diet. Obviously, try to take, obviously not trying to get fat, obviously eating more, like junk food or any substances that kind of put you in the obese conditions, might obviously increase the chances of bone fractures, and the way to obviously get rid of them is having more of vitamin D and calcium in your diet, and that way that also benefits your bones. And obviously that's the thing of being in a proper diet. And other emerging therapies in the field of molecular biology, it's the epirylation therapies, which is an antisense oligonucleotide, which deals with basically how it helps with the production of dystrophin gene. Could be one of those things which skipping of some exons, and that way that helps with the production of that leads to open frame reading, and then that leads to dystrophin production. Another thing that could be taken a look at is the CRISPR-Cas9, which could be applied for patients. Those are the ones bearing gene duplication. And let's go ahead with the case studies. For the first case, we have so for the case one, we basically for this medication for these two cases we used deflazacort, which is a derivative of prednisone, which we talked about in the previous slide, which is a glucocorticoid. It's a glucocorticoid. Basically, case one talks about the guy who had difficulty walking when he was 5 years old, and then when he was like around 7 or 10, he had some issues to run later in his life, and then so he had to use the Madeline gait, and his CK levels were 1106, which we can say is really high. I think for CK levels, if I can remember the top of my head, for men it's like 45 to 170, and we say it's like way higher CK levels, and the issue is that there's a deletion of exons from 45 to 47 of the DMD gene, and so this patient had later consumed deflazacort for about 30 milligrams a day, 30 milligrams for about 10 days in a month, and then increased the dose to 60 after like years of taking it. He'd taken about 60 milligrams for 10 days a month. And then there were similar progressions, very slow progressions. Like, as we know, we don't have any sort of like proper exact cure treatment for BMD. After 26 years, he was able to waddle, just able to slowly walk, put his hands on the table. Obviously, we know how it is. It's kind of hard for him to move, and it's been said that his triceps, his biceps, and all kinds of like the muscles are stable. Case two, which has another patient who had issues walking at 17, deletions of exon 45 to 49 of the DMD gene, and the next year he started taking 60. So this is, we can see he had issues at 17, so it's kind of a later stage in his life, not as early as the case one. And we see that he'd taken deflorazone 60 mg for milligrams for alternate days, and he had issues later in his life. He had around 25, he had issues climbing stairs, and then after 20 years of the treatment, we see that obviously he's taken more of those treatments, so it's worked well for him, and he didn't really have any side effects. Obviously, that difference from patient to patient. He didn't really have any of the side effects that we discussed in the previous slide about overweight and any of the stuff. After 20 years of the treatment, it's said that he was able to raise from chair from one hand, and was able to get up from the floor within like 10 seconds. That's it from my part. Thank you for watching.
Hello, I'm Madeline. So I'm going to be talking about recent experimental discoveries and pertinence to BMD and also ongoing clinical drug trials. So far, researchers have been using a very particular biomarker for BMD and also for DMD and other muscular dystrophies, and that is creatine kinase. So creatine kinase is usually an indicator for damaged muscle tissue. And so a high creatine kinase prevalence means it's usually a biomarker for muscular dystrophies, especially for BMD. And so researchers have been experimenting with a new possible biomarker, and it still is in sort of the same family, but it is an interesting approach. So basically, creatine is a biochemical that is found in liver, and it is also found in foods that can be digested. And what the body does is it takes creatine and it converts it to creatinine in healthy muscle. So, if you are looking for a biomarker for healthy muscle, you would expect to see a low creatine to high creatinine ratio. And so researchers with this hypothesis were like, how do we prove that this biomarker is going to be sufficient for testing for Becker's muscular dystrophy when we're doing a clinical trial, when we're testing for drugs, when we're testing success rates? So what they did was they took test subjects and they put them through the 6-minute walk test and the North Star ambulatory assessment test, and then also analyzed their creatine to creatinine ratios on the side. So they found that the correlation of a high creatine to low creatinine ratio was correlated with worse performance on these two ambulatory tests. And that is exactly what we would expect, right? If there's high creatine that is not being converted to creatinine, then that is an indication of unhealthy muscle tissue. And so obviously the patients would do worse on ambulatory tests such as the 6-minute walk test and the NSAA. However, it's really interesting. This only showed a weak relationship in proportion to creatine kinase levels. So we would normally expect to see high creatine kinase levels and a high creatine to creatinine ratio. However, during these studies, the correlation between them was very weak. And so that this biomarker is still a work in progress, but it is exciting that there's a new biomarker for BMD. All right. So another realm of recent experimental discoveries that are really exciting to talk about. So the fatality of BMD is usually correlated to cardiomyopathy, basically just the weakening and muscle degeneration of the cardiac muscle tissue. And so in order to combat that, cardiac therapies have been really worked on in order to see how we can increase the maximum livelihood of BMD patients. And so Capricor Therapeutics, which is a pharmaceutical company, developed this idea of a cardiac stem cell therapy called CAP1002. It basically takes cardiac stem cells that are derived from heart donor tissue. And what the researchers have done in this company is they're trying to transplant these therapeutic cardiac stem cells into BMD patients. And they found that these stem cells actually are promoting cardiac muscle tissue regeneration. And this is a huge combating enemy for cardiomyopathy. And it's a huge discovery because if we are combating the muscle tissue degeneration in the heart, we have a really good probability of increasing the lifespan and the livelihood of these BMD patients. With that being said, another approach to cardiac therapy has been created by Phase Biopharmaceuticals, and this is the therapy known as the vasoactive intestinal peptide, or for short, VIP. So VIP is basically a neuropeptide. And when researchers tested it, they found that it was shown to increase ionotropic contractions of the heart and speed relaxation of the heart. And basically, this neuropeptide was found to prevent the fibrosis, the fatty muscle tissue infiltration, and inflammation in cardiac and skeletal muscle tissue. So these two therapies are very much combating muscle degeneration of the cardiovascular system. And this is really important because the fatality of these muscular dystrophy diseases are very much tied to vital organs such as the heart. And so it's really important that we are continuing to discover and develop more cardiac-centered therapies for Becker's muscular dystrophy. Okay, so now I'm going to be talking about ongoing clinical drug trials. So Edgewise Therapeutics has been a big name in the BMD pharmaceutical world. And so they have been working on this drug for a while now. And basically, Edge 5506 is currently undergoing a phase 2 clinical trial. So the difference between, there's multiple phases of a clinical trial, and phase 1 is usually used on a larger majority of patients, and we are just trying, or on animals, mostly on animals, animal subjects. And basically they're trying to see like what the effects of the drug are, if the effects line sort of with a hypothesis, and then a phase 2 clinical trial is done on actual BMD patients, but a smaller number of BMD patients, so that the researchers are able to test side effects of the drug. They're able to test the safety of the drug. They're able to test how this actually works on humans, and if the effects of those animal trials really corresponds to what will happen if we'll put these drugs in humans. And so this phase 2 clinical trial used up to 66 boys and men ages 12 to 50. And basically, EDGE 5506 works by suppressing myosin to protect muscle fibers from damage and to eliminate the scar tissue buildup that leads to the fibrosis that we see in immunohistochemistry staining of BMD patients. And so this is one of the very few drugs that have gone through like phase 2 of a clinical trial that is undergoing such a breakthrough in BMD. And this therapy showed that the patients actually continue to tolerate the drug pretty well, even after 6 months. And the original dosage, I think, was about 10 milligrams, and now it's been increased to 15 milligrams, and target clinical levels of EDGE 5506 have been reached with the 15 milligrams. And target levels of creatine kinase have also been reached with the oral dosages. And so obviously the researchers wanted to test the patients to see if this drug was actually improving muscle tissue, and they found that motor function was improving when they performed the North Star ambulatory assessment on these patients. And then on top of that, the level of troponin in these patients was reduced by 75%, and creatine kinase levels were also reduced by 39%, which is absolutely is huge, especially because this drug they've only been taking the drug for 6 months. So that is an ongoing clinical trial that I would like to shed light on. And then the second clinical trial that I would like to shed light on is by this Ital Pharmaco group. And so it is a pharmaceutical group in Italy. And they're currently testing givinostat. And givinostat is basically a histone deacetylase inhibitor. And this histone deacetylase inhibitor is known to reduce fibrosis, again, like the muscle scarring and muscle fat tissue infiltration in these BMD patients. And so basically, givinostat has been used in DMD patients, and it actually showed there were a lot of improvements in histological effects and improvements in the muscle tissue in DMD patients. There was like reduction in fibrosis. So the point of this clinical trial, it is also a phase 2 trial, was to see if these givinostat results can be transferred to BMD patients. So they used 51 BMD patients between the ages of 19 and 61 years. And this clinical trial for phase 2 ran for about 12 months. And so this showed a significant reduction in muscle fat infiltration between the givinostat and placebo groups, which is very good. And basically there was like a significant difference in the amount of fibrosis between the givinostat, the drug experimental group, and the placebo group. And then also these patients were put through the 6-minute walk test, and there were no changes in the times that, in the results of the 6-minute walk test between the beginning of the 12 months and the end of the 12 months, which shows that givinostat is actually delaying the muscle deterioration we were expecting to see in this ambulatory test. We would have expected to see over 12 months a progressive decline in the ability to complete the 6-minute walk test. But since there was no changes, this indicates that givinostat is slowing muscle progression, the muscle deterioration progression. So this is in phase 2, and so it needs to undergo a few more phases before it can be FDA approved. But this is very exciting for the world of BMD. And these are all of the references that we use throughout this video. Thank you so much for listening, and we hope you learned something new and exciting about Becker's muscular dystrophy today.